Now second chapter of your class, polynomials. In class 9th you have covered definition of polynomials and types of polynomials, zeros of polynomials. But as a revision, again you have to note down and revise types of polynomial and zeros of polynomial. Polynomial. Let x be a variable and is positive integer. Then px equal to an x power n plus an minus 1 x power n minus 1 plus and last term a0. In other words, you can say an algebraic expression in which the power of variables in each and every term is whole number is known as polynomial. Here easily you can observe in px each and every term whatever written, power of variable should be whole number, then it is a polynomial. The highest power of x is known as degree of polynomial. Types of polynomial. As a revision, constant polynomial means a polynomial whose degree is 0, known as constant polynomial. For example, px equal to 7, px equal to 5. If px equal to 7 you can write 7 into x power 0. Since degree of polynomial is 0, therefore it is a constant polynomial. Linear polynomial means degree 1. For example, 2x plus 8. Here highest power of x is 8. Highest power of x is 1. Therefore it is a linear polynomial. Quadratic polynomial means degree of polynomial 2. For example, x square plus 4x minus 9, there are 3 terms. First term, power of variable 2. In second term, power of variable 1. And third term, 9, here power of variable is 0. Highest power of variable is 2. Therefore it is a quadratic polynomial. Cubic polynomial. If there is degree 3, it is known as cubic polynomial. Biquadratic polynomial means degree 4. If degree 5, 6, 7, then only you can say it is a polynomial whose degree is 5 or degree 6 or degree 7. Or also you can write the name of polynomial on the basis of number of terms. If there is only one term, it is known as monomial. For example, px equal to x square. Only one term is here, means monomial. And what is degree of this polynomial? Degree 2. Means combined form you can write it is a quadratic monomial or only monomial. Binomial having 2 terms. Trinomial, if there are 3 terms, it is known as trinomial. In case of binomial, trinomial, there is no importance of degree. Only have to count number of terms. Value of polynomial. In class 9th you have covered this part also. If any polynomial px is given and a is any real number, then the value of polynomial when you replace x by a is known as value of polynomial and denoted by pa. Let px equal to 7x square plus 4x and a equal to 3. Then the value of px at x equal to a equal to 3 is given by p3 equal to 7 into 3 square plus 4 into 3. 7 into 3 square equal to 63 plus 4 into 3 12. 63 plus 12 75. Zero of a polynomial. Real number a is called zero of polynomial if value of polynomial at x equal to a is 0. That is pa equal to 0. If pa equal to 0, then a is known as zero of polynomial. For example, px equal to 2x minus 4. Can you write here? Zero of this polynomial. If we replace x by 2, then the value of polynomial is 0. Therefore, x equal to 2 is a 0 of polynomial or 0 of px. Now next, geometrical meaning of zeros of polynomial. From here, class 10th syllabus start. Geometrically, zeros of polynomial are the x coordinate of the points where the graph of polynomial intersect or touches or crosses the x-axis. If you draw the graph of a polynomial, if it intersect x-axis at 2 points, 3 points, 4 points, at that point, x coordinate is known as zeros of polynomial. Graph of polynomial px of degree n intersect x-axis at most n points. Therefore, a polynomial of degree n has maximum n zeros. It is not necessary that intersect at n points only, at most n points. If you draw the graph of a quadratic polynomial, it will intersect x-axis maximum 2 points. It implies you will get maximum 2 zeros. On the basis of graph, easily you can count number of zeros of a polynomial. So these two parts are clear. On the basis of graph, zeros of polynomial and number of zeros of polynomial. First graph is here. If graph of polynomial intersect x-axis at 3 points, then you can write or you can say there are 3 zeros of this polynomial. In second graph, it intersect x-axis at 2 points, means there are 2 zeros. Second topic in this chapter, polynomials. Relationship between zeros and coefficients of a quadratic polynomial. If alpha and beta are zeros of quadratic polynomial, px equal to ax square plus bx plus c, where a not equal to 0, then we can say x minus alpha and x minus beta are factors of px. If x minus alpha and x minus beta are factors of px, then we can write ax square plus bx plus c equal to k into x minus alpha into x minus beta, where k is non-zero constant. If we open the bracket and simplify, we will get kx square minus k into alpha plus beta into x plus k alpha beta. Now, comparing the coefficients of x square, x and constant term, in both sides, we will get values of a, b, c as a equal to k, b equal to minus k into alpha plus beta, and c equal to k alpha beta. From first and second, simplify, we will get alpha plus beta equal to minus b upon a, or you can say sum of zeros equal to minus coefficient of x upon coefficient of x square. That is the first relationship between zeros and coefficients. From first and third, c equal to a into alpha beta, or further you will get alpha beta equal to c upon a, or product of zeros equal to constant term upon coefficient of x square. Above result we can summarize as, if alpha and beta are zeros of quadratic polynomial, then directly we can find the polynomial using this formula, k into x square minus alpha plus beta into x plus alpha beta. Or also we can write this as k into x square minus sum of zeros into x plus product of zeros, where k is a non-zero constant. Some questions for practice. First question. Sum of zeros given as minus 4, product of zeros 1 by 2. We have to find quadratic polynomial. Use formula px equal to k into x square minus sum of zeros into x plus product of zeros. By putting the values, you will get k into x square plus 4x plus 1 by 2 by taking LCM, k upon 2 into 2x square plus 8x plus 1, where k is non-zero constant. For different values of k, you will get different polynomial having the same condition as sum minus 4 and product of zeros 1 by 2. Second, polynomial is given. You have to find zeros and also verify the relationship between zeros and coefficients. X square plus 7x plus 10. You can factorize it, and factors you will get as x plus 2 into x plus 5. Therefore, zeros of polynomial are minus 2 and minus 5. Now relationship. Sum of zeros minus 2 plus minus 5 equal to minus 7 equal to minus 7 upon 1, and which is equal to minus coefficient of x upon coefficient of x square. Product of zeros minus 2 into minus 5 equal to plus 10 equal to 10 upon 1 equal to constant term upon coefficient of x square. Hence relationship between zeros and coefficients verified. Now some questions for practice. In first question, you have to find zeros, and after that verify the relationship between zeros and coefficients. Second question, you have to find quadratic polynomial if sum and product of zeros are given as minus 8 upon 3 and 4 upon 3. In third question, again you have to find quadratic polynomial if sum and product of zeros root 2 and minus 3 upon 2. Also you have to find zeros. It implies first you find quadratic polynomial, after that factorize and find the zeros of polynomial. Now last topic of this chapter, division algorithm for polynomials. Already in class 6, 7, 8 and 9 you have covered when you divide any number by second number, the dividend, divisor, quotient and remainder. Also you have covered in previous class 9th, when any polynomial px is given, if you divide by gx, the process to find qx, quotient plus remainder, where remainder will be 0 or degree of remainder less than degree of gx. Now some example. If first polynomial is given as 2x cube plus x square plus 2x plus 3, divide by x square plus x plus 1. This question is for revision. In class 9th you have covered, in class 8 you have covered division of polynomials. X square plus x plus 1. Dividend we can write as here 2x cube plus x square plus 2x plus 3. Then step first, how many times? 2x times. And step by step we follow. And after solving, quotient is 2x minus 1 and remainder x plus 4. And here degree of remainder is less than degree of divisor. In this pattern, if any polynomial is given, you can divide by other polynomial and you can find the value of remainder and quotient. Now second question. This question or this type questions are very important for board exams. If any polynomial is given as x power 4 plus 4x cube minus 2x square minus 20x minus 15 and two zeros of polynomial given, since the degree of polynomial is 4, it implies you will get 4 zeros of this polynomial. 2 zeros given, you have to find other 2 zeros of this polynomial. Step first, note down px. Since 2 zeros given, write down root 5 and minus root 5 are zeros of px, or x minus root 5 and x plus root 5 are factors of px, or product of these two, x square minus 5 is a factor of px. Same step you have to follow to solve any question of this type. Now, in next step, divide px by x square minus 5. X square minus 5. Px means dividend x power 4 plus 4x cube minus 2x square minus 20x minus 15. Division algorithm, all of you know. Divide and find out remainder. After solving, easily you can observe remainder is 0. Now apply division algorithm. Dividend equal to divisor into quotient plus remainder, or px equal to gx into qx plus rx. Put the value. Px means x power 4 plus 4x cube minus 2x square minus 20x minus 15 equal to gx x square minus 5 into qx x square plus 4x plus 3 plus remainder, that is 0 here in this question. X square minus 5 already given, two factors means x minus root 5 into x plus root 5. Now x square plus 4x plus 3 have to factorize, split middle term and continue the process. X common, x plus 1 remains, plus 3 common, x plus 1. Now again x plus 1 common, x plus 3 remains. In this pattern you are getting 4 factors of binomial px. It implies there are 4 zeros of px: root 5, minus root 5, minus 1 and minus 3. That is the process to find all zeros of any binomial whose degree is 4 if 2 zeros of binomial given. Now some questions for practice. First question, 2 zeros of binomial given as 2 and minus 2. Find other 2 zeros. In question number 2, again same process, 2 zeros given as 2 plus root 3 and 2 minus root 3. You have to find other 2 zeros. And third question, if the remainder and division of binomial by x minus 3 is given as 21, find the quotient and value of k. And hence find the zeros of cubic binomial x cube plus 2x square plus kx minus 18. Complete these questions and submit your answer.